So a while ago I picked up one of these RN-42 Bluetooth modules, and it sat around in my parts bin for a while, and finally I sat down a few days ago and decided I'm going to figure out how to work with this thing. So what we've got here is the RN-42 with a standalone Arduino. So this is just an ATmega328 IC chip in a breadboard, mounted in a way that and configured in a way that you can use the Arduino IDE to program this. So I came into this project with three goals. Number one, I wanted to be able to wirelessly send and receive data via Bluetooth, but also be able to do it from a PC or Mac using the Arduino IDE's serial monitor window. So if I open up that window, I wanted to be able to type in hello world. That would be sent over via Bluetooth, and it would be received by the Arduino, and vice versa. So I could also read data from the Arduino. And that's exactly what this simple circuit does. So what I have here is two temperature and humidity sensors hooked up to the analog inputs of the Arduino. That data is then sent over wirelessly to whoever's listening via Bluetooth. So we'll talk about all that. That was my first goal. My second goal was slightly more complicated. I wanted to be able to program the Arduino via Bluetooth using the Arduino IDE. So I just hit upload, and then it sends it over through Bluetooth to the Arduino, and it would program seamlessly. Okay, that was goal 2. Goal number 3 was, which I did not meet. I didn't hit this goal, and I was kind of ticked off for the reasons why. But I wanted to use the HID protocol, which means you can behave like a keyboard, a Bluetooth keyboard or a Bluetooth mouse, and you could even send data, and you could do all kinds of cool stuff. I was not able to meet that goal. That would have been a cool thing to do, because things like, smartphones or like, my iPad, I could have actually behaved like a keyboard, and I could have actually, wrote data into apps and different things like that. But the reason I could not hit that goal was because this RN-42 does not come loaded from the factory with the HID firmware. It says in the manual that maybe in a future release or something that you can field program this device, but for right now you can't. You actually have to order a separate RN-42, which is the identical hardware as this one I have here, but it comes loaded from the factory with the HID firmware unlocked or loaded in. So anyway, I wasn't about to go out and buy another RN-42 just to do that. Maybe I will someday, but for this not, because as you can tell, I didn't have a breakout board for the RN-42, and it's a really fine pitch connection. So I had to sort of manually solder it onto one of these surface mount breakout boards. This is what they call a smart board I had laying around. So I hooked it all, I soldered it to that, and it was kind of amazing that even worked. Then I soldered these tiny itty bitty little wires to the bottom connections out to breakout pins, and everything is broken out through ribbon cable to these headers where I was able to access all the pins. I do not recommend doing this. If you're going to buy this module, make sure you buy it with some kind of breakout board, because it was almost impossible to do this. This took me longer than the entire circuit and all the programming. So anyway, if you're gonna buy one of these modules, make sure to get a breakout board, because it is not worth the time and headache to do this. So anyway, I got that all set up. I got the circuit working. I was able to hit goals 1 and 2, so I'm able to send and receive data, and I'm also able to program the Arduino using both a PC or Mac. So now let's talk about the hardware connections. Okay, so this is pretty simple stuff. We have the RN-42 over here, and we have the Arduino IC over here, and this is the ATmega328 IC. So, if you're using something else like, the Leonardo or one of the newer Arduinos, that you may not, this circuit may not work. You might have to figure something else out, or actually solder these connections into the board itself. Not solder them, but plug them into the headers. You know what I mean. So here's the major problem with this circuit. The RN-42 operates on 3.3 volts. The Arduino, or the ATmega328, operates on 5 volts. So the RX and TX lines need 5 volts, 5 volt logic levels. Okay, And same thing with the RN-42. They need 3.3 volt signals. So basically, let's go through this pin by pin. Okay, on the RN-42 side, things are pretty straightforward. The ground pin, you ground, obviously. GPIO 7 or pin 4 is the baud rate select. We're going to ground that pin via a 10k ohm resistor. Okay, when it's grounded, that lets you configure the baud rate for anything you want. If you pulled this high, and so instead of going to ground, if you made it go to 3.3 volts, remember this is all 3.3 volts. If you tie anything over here to 5 volts, you could blow up the chip. So if you ground this, it's programmable. If you bring it high, it fixes the baud rate to 9600. Okay, next pin, pin 11, that's 3.3 volts. That's your input source voltage. Pins 13 and 14 are the RX and TX, and I'm labeling these RXB, TXB for Bluetooth. On this end, they're RXA and TXA for Arduino. CTS pin, that's something that has to do with like serial communication. Clear to send, I think it stands for. We're just going to ground that pin via a 10k ohm resistor. There's another pin called RTS, and we're not going to use that pin, so just let it float. Pin 21 we actually use as a status output. So this, we just simply drive an LED. So through a 1k ohm to an LED to ground. And then this blinks and tells us things if it's connected, if it's in discovery mode, you know, things like that. Pin 22 is the factory reset input pin. Now, you're not going to use this pin a lot, but if you screw something up in the configuration, you're going to be glad you have this pin broken out so that you can quickly just reset the defaults and start over. Okay, I've done that like 20 times with this chip, trying to figure out how to work with it. So anyway, moving along here. Oh, it's just basically, by the way, it's just a 10K floating out there. This is how I did it. If it's open, it's not going to reset. If you pull that 10K up to 3.3 volts, that's what resets it. And it's actually like a sequence. So you have to like power it up with the 10K ohm tied to 3.3 volts. And then you cycle it like 3 times. And then it resets the defaults. Pin 33 is a general purpose I/O pin, but on default, it's configured as a DTR pin. And we need that pin. That is the data terminal ready pin. So this DTR pin ties into the Atmega 328. So over here, these are the physical pins of the IC, okay? Not your Arduino pins when you look at the board. So pin 0 of that, the very first pin on the top left, you know, if the divot's right here in the chip. We have the standard reset circuitry here. I'm going to forget about DTR for now. Well, I'm going to work my way towards it through this circuit. But anyways, you pull this pin up to 5 volts, because on this side everything's 5 volts. You pull it up to 5 volts with a 10k ohm resistor. In series then with a 0.1 microfarad capacitor. This is just a little ceramic cap. Usually says 104 on it. And then here we usually connect the reset signal from the USB to serial converter, but because that's not in the picture, this guy's replacing that. You needed this little circuit here. Because it turns out that this DTR pin, instead of going from high to low, like we're used to over here, it goes from low to high. So what we need to do is invert it. And that's what I've done here with a little transistor. So this outputs into a 10k ohm resistor, which drives the base of an NPN transistor. And this is a 3904. I should probably write that down here. 2N3904 transistor. Just a standard general purpose transistor. And you could use any one you want. But I use this to invert the signal. So normally when this signal's low, this signal right here is being pulled up high via a 10k ohm resistor to 5 volts, and it's connected to the collector of that NPN transistor. The emitter is tied right to ground. So when this is low and the base is low, the transistor is off and the signal is being pulled high. As soon as that DTR pin goes high, it saturates this transistor, which basically turns it into a short right here and pulls this line low, which this little time constant here will pull this signal low, and then this will charge back up, putting the Arduino into a reset state, which you need to program the bootloader in. So as soon as this DTR pin goes high, it resets the Arduino, and then the TX and RX pins go nuts. Okay, and it loads in the program for you. Okay, moving down the line here. So that's the reset pin, the RX pin, TX, RX, and then I just put this in here to show you, what you need to do a standalone Arduino. So you've got VCC to 5 volts, ground, and then OS1, OS2. These are your oscillator inputs. So that's your 16 megahertz crystal with 2 like little 22 picofarad connector or capacitors tied to ground on each line. And then of course you should sprinkle in 0.1 microfarad capacitors all around your VCC and grounds. One over here would be nice, and one from 3.3 to ground over here as well. So that's pretty much the whole circuit. Now you're probably asking yourself, where is the level shifting circuit? And that's okay. So I've done a million level shifting circuits, but basically what we're doing here is my TX and RX on the Arduino side are at 5 volts. So they're going to be switching from 0 to 5 volts. Or the TX is switching from 0 to 5 volts, and the RX is expecting a signal from 0 to 5 volts. On the RX and TX for the Bluetooth side, the RN-42, it's expecting levels of 0 to 3.3 volts, and it outputs 0 to 3.3 volts. The TX to the Arduino really isn't going to hurt the Arduino because it's just going from 0 to 3.3 volts. In fact, 3.3 volts here, that high 3.3 volts, might be enough for this to receive it. It might actually be able to process it, so you might not even need to level shift it. On the Arduino side, when it's sending out signals from 0 to 5 volts over to here, you could just use a voltage divider and divide it down to 3.3 volts, and that would work fine as well. But I like to always try new level shifter circuits. So what I used was this transistor type circuit, and basically what this is, and these are again 2N3904 transistors, pretty standard stuff. And basically what we're doing here is tying the emitter to the TX side, okay? And then we pull the collector up to the voltage that we're driving, okay? So it's a 10K ohm to 5 volts over here on the RX, and a 10K ohm to the 3.3 volts over here, okay? Same circuit, and then a 1K ohm to the base on both sides. And what's interesting about this circuit is, I've never used these before, by the way, but they do work. But what's interesting about this circuit is that the transistor is a simple just pass-through type device because it's always saturated. It's always turned on. So when this is high, in this case, this would be at 3.3 volts. This is high, okay? So it doesn't matter. It doesn't mean anything. It's just being pulled up high. When this goes low, that pulls this resistor down, okay, to 0 volts. Over here, it's the same thing. When this is at 5 volts, this guy's stuck at 3.3 volts, okay? When it goes, where was I at? Oh, I was actually over here. Yeah, so when this goes then to 0, this passes through, and it pulls this down to 0 volts. I've never really dealt with this type of circuit before, but I think in this case, I don't know how much it's needed. But anyway, that's the circuit. This is what I use. And again, you don't have to use this. And you can Google level shifters on the internet, and you might be able to find little chips that do this for you, actually. So you have just, one chip that has TX and RX, and it'll actually shift it for you. But this is one way. You can use optocouplers. You can use anything you want. But I just wanted to play around with a new type of circuit, so this is what I used. All right, so we're going to start off by pairing up with the Bluetooth module. I already reset the module to default, so this is how it would come out of the box as soon as you power up. And you notice when you first power up, the LED will blink very quickly. It'll blink really quickly like this for 60 seconds, and then it goes into its normal mode. anytime before that 60 seconds is up, you can go into remote configuration mode, and I'll explain what that is here in a second. So let's go here, and we're going to do this on a Mac first, but we go up to Bluetooth. Make sure your Bluetooth is on, obviously. Set up Bluetooth devices. Okay, and now it's discovering, and there it is. Now when you reset the defaults, it's going to reset, it's going to still keep its name. That's why it's showing up here as temperature, but in your case, it'll be like RN-42, blah, blah, blah. Okay, it's already paired with it, so it remembered it. But I'm going to try to connect to it. Okay, and it says unsuccessful. So you have to go to passcode options and make sure you go to 1, 2, 3, 4. That's the default code. And go ahead and pair with it, and this should work. Okay, and you only have to do this once. Okay, everything's good. It created a serial port for us. So now what we should be able to do is go in now to the Arduino IDE, and we should be able to see from tools, the serial port, we should be able to see the TTY temperature SPP. So that when you see SPP, that means it's in a serial port type mode. Okay, and I should be able to open up a serial monitor, and this little icon should go to like a goofy connected symbol. Now this is the thing with Bluetooth. For some reason it always takes me like 2 or 3 tries to actually get it to work. It always says it's already in use. Okay, come on, baby. Nope, nothing. Try that again. Up, and there it goes. So it took me 3 times. Now right now it's sending out garbage data to me. That's because I reset it to defaults, and I have the baud rate selected as configurable baud rate. You know, through that one pin, it's connected to ground via a 10K resistor. So the default baud rate right now is 115/200. So I'm going to change that, and then of course it disconnects me, and oh, now it works. So this still is spitting out garbage data because the Arduino's baud rate that I programmed was set to 57,600. But anyway, first thing we need to do is change the baud rate of the Bluetooth module. To do that, we go into the user manual here, and we got to figure out what the code is for that. Okay, and we go down, down. And it's something like SU, I think. Somewhere in here. There it is, SU. That's the rate. But to enter command mode, you have to enter in 3 $signs. Okay. Right in a row, and then you send them down without a new line feed. But notice that this LED here, well, now it's not blinking at all. That's because we're connected to it. But the only way to enter into command mode is when the LED is flashing quickly. So that means I need to disconnect from here, and I need to power cycle the Bluetooth module. Okay, so now it's blinking very quickly, and you only have to do this when you're in remote configuration. And when I say remote, we're connected to it via Bluetooth. So I'm going to hit the 3 $signs here. No new line ending, and look, it says command there. It's really tiny on this screen. Oh well. So now we're going to change the baud rate to 57,600. So SU, 57. It only needs the first 2 numbers. Okay, and I got nothing back from it, which is very weird. Did I send that right? SU, 57. Yeah, what the heck? Oh, I know what. This one will get you. This is one of those gotchas. So when you enter into command mode, you keep this at no line ending. So there's no carriage return or no new line feed. When you start sending commands to it, you have to change this to new line. So now if I go SU, 57, enter, it gives me an acknowledge. So it's saying A-OK, everything's good. So it did change the baud rate to 57,600. And there's a reason I changed the baud rate, and I'll show you why here in a second. But there's one more thing we have to change. So there's all kinds of cool stuff we can change in here. In fact, why don't we change the, I don't know, maybe the text. We could change that text. I think it's serialized friendly name of device. I think that's the one. So if we want to change that, we do I think this is the one that you change it. I'm not sure. Name of device. Oh, I think it's just SN. So if I go SN, comma, I'm going to call it, I don't know, YouTube. And then I'll hit OK. OK. So it changed it to YouTube. So baud rate was changed to 57600, and the name was changed to YouTube. Now I'm going to keep going down here and see what else I can do, because there is one more thing I have to do. There is the mode. Yes. Or the profile. I have to change the profile to MDM SPP with modem control signals. This is only needed when you want to program the Arduino. This enables that DTR pin I was talking about that resets the chip. Uh-oh. Where'd my screen go? Oh, there it is. So I need to do an S, little squiggly line, comma, and then 3. Okay, I need to put it into that modem control thing. And if you've got one of these chips that has HID enabled, there's probably more modes here, or I don't know if it's here or maybe in the mode selection. Okay, let that rip, and we're good. Now we have to exit, and that's 3 dashes. Exit, end. So now it's back. And now I'll close that. And let's open up the Arduino again here. Now what we're going to do is power cycle the Bluetooth module. You have to do this so that the baud rate changes. Okay, I power cycled it. Now I wonder what the name is going to pop up as now. Oh, it's still temperature. That's weird. Maybe it's another thing in there, but I changed something in there. I don't know. Oh, there it is. It changed names. You see it? YouTube. Okay. Okay, it's saying it's already paired, so I probably don't have to go through that process again. Or maybe I do. Let's find out. So I'm going to open up the serial window. Now the baud rate should be at 57600. So let's open this guy up. And of course it takes me a few tries. Come on, baby. I don't think it worked there again. Oh, I see. Look, it's trying to open up temperature. So I do need to do that process again. So let's do that again. Come on, come on, come on. YouTube, continue. Continue. Okay, attempting to pair. It should ask me for the passcode. And by the way, guys, like I said, I just started playing around with this thing a few days ago. So you're going to have questions specific to your application and your circuit that I probably won't be able to answer, just as a fair warning here. Okay, come on. Good. Now, we should be able to see that serial port. There it is, YouTube SPP. And then I'll click this, and it should open it up. Maybe after 3 tries. Got it the first time. All right, see, it's sending me the data now, but I'm going to change the baud rate, and everything looks good there. You probably can't see that. I'm going to change that. I'm going to disconnect again. I'm going to reopen it just so we can see it. Okay, look. Now we're seeing the temperature in Fahrenheit of the 2 sensors and the humidity of both sensors. Okay, that's pretty good, and we can send and receive data. But the thing I talked about was actually being able to program the Arduino. And, oh boy, to do this, it turns out that your board needs to be selected as the Arduino Bluetooth BT with ATmega 328, which programs the board at 57600. That's why we changed the baud rate. And then the serial port. Now, okay. Now remember, the last time I showed it to you, this was all blank. It did not say from Mac. I know you probably can't see this, but basically I want to distinguish and prove that I'm actually programming it. So I'm going to hit upload. And this sometimes takes a while. Okay, so I don't think it's going to work. No, it did not work. I have to do it again because I'm watching this symbol up here. There it goes. It connected. Okay, so it's connected now. The LED turned off. That's how I know it's connected. And it's done uploading. Now I'm going to open up the serial window, and hopefully we see RH from Mac, because I did change that little piece of code. Obviously I have to do it more than once. Come on. Come on. There's probably a little something I could do in here to make this easier. Make sure I still got this here. Yeah, I do. Let me try that again. Come on, there it goes. Okay. Oh, it did not change. Okay. So that is not good. All right, I'm going to try this again. I know this works. Okay, there we go. We're going to try this again. Uploading. Uploading. 57,600 is my baud rate. And it takes a while. It takes a lot longer than just this standard cable, but if you need a wireless way to program it and you don't want cables attached to your computer, I mean, your computer's got Bluetooth built in, so it kind of makes that easy, but trust me, you don't have a lot of distance with Bluetooth. And like I'm showing you here, it is finicky as all hell. It's not rock solid. You have to try things a few times. And again, I'm brand new to this, so I'm sure that I'm doing a million things wrong here. So look, it's still uploading. It's taking forever, but I know it's doing it. Okay, done uploading. Now let's try it. Come on. Okay, it's got to say it. Yep, it worked. So now it's saying from Mac. So it works. But again, I don't know what happens if you try to load a giant program. Like, I originally bought this to program the LED cube, my 8x8x8 LED cube, which is a massive program. I don't know how reliable this would be. So you got to think about things like that. But if you just need some simple data to go back and forth, this is the way to go. Okay, so that's on a Mac. Let's go to the PC now. All right, so let's take a peek over at the doing the same exact thing on a PC. And I know this is kind of hilarious, but I don't have good screen capture recording software installed on this machine. So we'll have to just make do with a camera. But there's nothing really to see here. I just want to kind of explain how it works. So for the PC, I don't have Bluetooth built in. I actually have this really cheap little dongle that I plug in, and then I get a little Bluetooth icon down at the bottom of the screen. I did not reset the defaults on the RN-42. I'm going to leave it the way it is. So we already set up the baud rate and the profile, and we changed the name to YouTube. So that's all going to be the same. By the way, if you want to enter into, I guess they call it command mode, you don't have to do it over Bluetooth. If you have a USB to serial converter, you can use the RX and TX and tie them to the RX and TX of the module, and you can do the $3 signs and enter into command mode that way. So if you're having a hard time connecting, you could connect locally, and for that you don't have to wait for or you don't have to do it within the 60-second window. You can do it anytime, as long as you're not connected to another device. But anyway, okay, so we plugged it in, we get this Bluetooth module, and I'm going to go to Show Bluetooth Devices. And I'm going to click Add Device. Let me make sure I'm recording. Okay, yeah, I am. And it's searching for devices. And man, this dongle, I don't know if it's a piece of crap or what, but it takes forever and the distance is awful. I think I got this module for like $4. So something popped up here, and it says YouTube. So that's our device. We hit next. Select pairing option. Enter the device's pairing code. It's 1, 2, 3, 4. Next. Yeah, and it's installing stuff for me. The device has been successfully added to this computer. Now I'm going to show you a few little things about Windows. For some reason, with this module, it helps a lot if you go over and go to Open Settings, click on the little blue Bluetooth icon, and make sure that your discovery is enabled for the PC. So allow Bluetooth devices to find this computer is enabled. For some reason that helps when you're trying to connect. Otherwise, sometimes the driver doesn't show up. So let me show you a couple things here, which is cool. So normally on a Windows, when you plug in that little USB to serial converter, you'll get a COM port like COM3, COM4, and you go to Device Manager, which I'm doing right now, and you'll see that little COM port pop up, which is kind of nice. Then you just, you know, in your Arduino IDE in your program over here, you go to tools and then you click the port and you go to like whatever COM it is. Right now I installed that and I go down here to ports COMs and I see a new COM port was created for me for the Bluetooth module, COM45. So I'll use COM45. Let me actually go here and make sure. Now, yeah, I have a couple other COMs in there too, but I want to make sure that that one I just selected was it. So I'm going to go to Show Bluetooth Devices, and then it opens this up, and I see YouTube right there. I'm going to double click on it. I'm going to click Hardware, and it's showing me it's COM44. Okay, so I was actually wrong. I don't know what COM45 is, but it's COM44. I go to Services. Okay, this takes a while because it's actually pulling the RN-42 to tell the computer what it's capable of doing. So you want to make sure that the checkbox for serial port SPP is selected, obviously. And that's pretty much all you can do there. So right now, in my Arduino sketch, I should be able to go to Tools. Okay, and of course it's a PC, so everything takes longer. And I should be able to see the COM44. Okay, and I do. Now, if I open up a serial monitor window, it should connect, and I should be able to see the data, that temperature data. And right now, it should say from Mac, because we just programmed it, and sure enough, it does. You probably can't see that, but it does. So we can send and receive data from the Arduino. That's goal number 1. Goal number 2 now, can we program it? I believe we can. Serial port 44. Board Arduino Bluetooth with Atmega 328, and we're gonna go ahead and hit upload. Come on, baby, let's see if it does it the first time. It never does. So it's compiling the sketch, it's uploading. I'm watching the LED over here. It just turned off, so I know it connected. It's uploading. Takes a lot longer than regular. I think it's because it uploads it very quickly, but then it waits for some acknowledgement from the Arduino. But since it's all over Bluetooth, I think all that is delayed. So it says done uploading. And now, instead of it saying R8, the last line saying from Mac, now it says from PC. So I should know that it was successful. So I'm gonna open up the serial monitor window. Hopefully it opens. It never does the first time. I don't think it did. I think it crashed. Because I'm watching the LED over there, and the status LED should turn off. And it didn't, so I think it's sort of crashing on me. Yeah, COM44 already in use, so I'm gonna try it again. Come on. There it goes. There it is. So it worked. So now it says the data from PC, so everything works, okay? And that's pretty much it. That's how to work with Bluetooth. I mean, this is how to send and receive data. So in my program, I would use COM44. In my processing, in my Visual Studio, anything, I would use COM44 to get access to the module, or to my Arduino. I don't think I can use, I was just thinking out loud there, it'd be kind of cool if you can connect 2 computers to one device, so it's sending out data to 2 computers, but I don't think that's possible. Anyways, I'm still kind of new at this, and usually I don't make videos, you know, when I'm kind of rusty like this and I'm figuring it out for myself, but I want to move on to another project and I'm going to rip up that breadboard, so who knows when the next time I'll build something for Bluetooth. So anyways, that's the video. Thanks for watching. I hope that helps, didn't confuse you to death, and hopefully it wasn't too long. I think I was mumbling and rambling there for a while and nothing, but anyways, hopefully that helps. Thanks for watching.